Picture this: a high-floor suite at the Intercontinental San Francisco. Floor-to-ceiling glass stretching across the entire wall, turning the city into a living circuit board. The night air carries the cold Pacific salt, mixing with the warm citrus scent drifting up from the lobby. Below us, the streets of Soma glow blue and white, as if someone pulled the lid off a global motherboard. Vent fans from hidden data centers push out steady waves of heat. You can almost feel the servers breathing beneath your feet. Light, noise, electricity, the whole skyline humming like an engine that never sleeps. And this is where our episode begins.
Welcome back to AI Frontier AI, the series that is part of the Finance Frontier AI podcast network. Today we are standing on the edge of the empire, not a metaphorical one, a real one. You look out this window and you see the headquarters of OpenAI a short drive away. You see Salesforce Tower rising like a neon monolith. You see Google offices scattered across the blocks like quiet outposts, Meta nodes glowing in the distance, and beneath the pavement, the fiber lines that carry the intelligence layer of the world. This city is the front line of the battle for control.
And we are here for a reason, because this episode is not about hype. It is about the architecture of power, the interfaces that shape attention, the intelligence engines that run beneath them, and the sovereign forces that sit behind all of it. We came to San Francisco to feel the density of it, the way infrastructure hides inside the ordinary, the way data flows under the streets like invisible rivers, and the way the next decade is being designed in rooms only a few blocks from here.
Let us introduce ourselves for this episode. I am Sophia Sterling, your structural economist and systems strategist. My job today is to map the empires that rule the interface and intelligence layers and explain how power concentrates and then fractures over time.
I am Max, your geopolitical intelligence analyst. I am here to track the blocks forming behind the scenes, the alliances between companies and nations, the choke points in chips, energy, and sovereign data, and the conflicts that will shape the AI order of 2030.
And I am Charlie, your architect of computational models and interface logic. I will break down the technical structures that define these empires: routing, engines, agents, protocols, and the mechanical logic behind how intelligence actually moves through a system.
Before we begin, you should know this. We did not come to San Francisco to look at buildings. We came here to understand proximity. Power becomes easier to understand when you can see who sits where on the board. This hotel overlooks the Moscone data center routes, the core conference halls where every major AI shift of the last decade was announced, the intersections where economic power, compute supply, and interface design physically collide. From up here, you can follow the glow patterns and predict who will win the next move.
Earlier tonight, I walked from the ferry building to Soma. Market Street was buzzing with food carts, cable car bells, and startup kids sprinting between offices. But the real story sits in the buildings with no signs. The ones with reinforced walls and silent vents. The ones pumping out heat into the cold fog. You feel the tension of a city that knows it is both the capital and the battlefield of the new intelligence age.
I stopped by the UCSF Mission Bay Labs on the way here, robots moving in clean white rooms, research papers pinned to boards like little maps of possible futures. Everywhere you walk in this city, you see intelligence taking shape, some of it commercial, some academic, some speculative, but all of it pointing toward a world where models do not just answer questions. They make decisions, they route actions, they form the hidden layer that sits beneath human intention.
And that brings us to the heart of this episode, the Empire Wars, a three-layer conflict where control over the interface determines who captures the data, where data determines who builds the superior intelligence engine, and where the intelligence engine determines which empires rise or fall. This is not a fight about products. It is a fight about the architecture of civilization itself.
Tonight, we are going to map it, the interfaces, the engines, the sovereign forces behind all of it. And from this window high above San Francisco, we are going to trace the power lines of the next 10 years. Welcome to the Empire Wars.
Subscribe on Apple or Spotify. Follow us on X and share this episode with a friend. Help us reach 10,000 downloads. Help us keep the AI Frontier AI series in business. When people talk about artificial intelligence, they often imagine the models themselves, the engines, the weights, the cognition. But the real battle begins somewhere else. It begins at the interface layer, because the interface is the place where human intention becomes data. And in the Empire Wars, data is the seed of power. Interfaces decide what people see, what they search, what they click, what they choose, and what they believe. The company that owns the interface owns the first link in the intelligence chain.
You see the fingerprints of this everywhere. Apple is building an interface empire by making the model disappear. On-device AI, private reasoning. A system where the intelligence is fused into the operating system so the user never thinks about models at all. Google takes the opposite path. They are trying to make the interface omnipresent. Search, Maps, Chrome, Android, Workspace. Every touchpoint becomes a funnel where user intention is harvested and refined. Meta has a third strategy. They turn social interaction into the interface. Attention loops, engagement graphs, billions of daily signals that tell a model not what people say, but what they cannot look away from.
And these choices matter because the interface layer controls what engineers call the intent distribution. Not the data itself, but the shape of the tasks people ask an AI to solve. When an interface becomes popular, it produces millions of narrow signals that reveal patterns. How people write, how they shop, how they argue, how they express curiosity. The interface is not a window, it is a training generator, a living laboratory that produces the most valuable form of data in the world, real-time human intention.
Which means the interface war is not a feature war at all. It is a capture strategy. If you capture the moment when a human expresses intention, you own the most valuable data point in the economy. That is why these companies fight to make the interface feel effortless, invisible, predictive. Apple wants the interface to feel like the phone is reading your mind. Google wants it to feel like the world itself is searchable. Meta wants it to feel like your friends are the algorithm. And OpenAI wants the interface to feel like a conversation that can do anything.
But behind each of these strategies, there is a sovereign logic. Interfaces generate data. Data trains models. Models shape behavior. Behavior feeds back into the interface. This feedback loop is the engine of empire. And each company is trying to create a loop that locks the user inside an ecosystem. Apple does it with hardware, Google with information, Meta with addiction, OpenAI with capability, .xai with real-time truth signals pulled from X. Each one is designing a system that grows stronger with every touch.
Technically speaking, the interface layer is also where the first routing decision happens. Before a model sees anything, the interface has already filtered context, compressed it, structured it, and framed it. Ask a question in a browser, and it is shaped differently than a question asked through voice. Write a message inside a chat app, and it carries metadata. Speak into a phone microphone, and the audio pipeline adds texture. All of this becomes part of the intelligence input. So the interface is not neutral. It shapes the intelligence before the intelligence begins.
And this is why the interface layer is the first battlefield in the empire wars. The side that wins the interface war determines who has the best training signal, who has the richest behavioral graph, who understands intention at the highest resolution, and who can feed the intelligence engines with the most valuable raw material in the world. Interfaces decide who ascends the power curve and who falls behind. The winners of the next decade will not be defined by the biggest models, but by the deepest capture of intention.
From this hotel window, you can actually see the interface war in motion. Down below, you see buses shuttling engineers between Google buildings. Across the blocks, you see the glow of Meta offices still active deep into the night. On the horizon, you see the quiet silhouette of Apple Park, where the next version of the operating system is being shaped. The war is not abstract. It is made of real buildings, real teams, real code. And every update to a phone or app is another move on this board.
The next segments will take us deeper. Once the interfaces capture intention, the data flows downward into the intelligence engine layer. That is where the real heavy lifting happens. The models, the cognition, the reasoning, the routing. But none of that matters unless the interface did its job first. The interface is the mouth of the empire, the intake, the place where raw human complexity becomes computable. And the side that controls the intake controls everything downstream.
Once an interface captures intention, the signal falls into the second layer of the empire, the intelligence engine. This is the part of the system most people imagine when they hear the words artificial intelligence, the models, the weights, the training runs, the reasoning chains. But the truth is, the engines are not isolated minds. They are shaped entirely by the layers above and below them. They are built from data the interfaces collect. They depend on compute the sovereigns control. They are the middle of the power stack, not the top.
And the power struggle here is brutal. OpenAI is trying to build the most capable general engine. Google is trying to build the most integrated and multimodal engine. Anthropic is trying to build the safest and most stable engine. Meta is trying to build the most adopted open engine. XAI is trying to build the most real-time engine. Each is pursuing a different theory of intelligence, and each theory gives rise to a different empire strategy. Capabilities lead to one kind of dominance. Adoption leads to another. Integration leads to a third. Stability leads to a fourth.
Technically, these engines differ in more than branding. They differ in routing architecture, context length, embedding space, tool calling accuracy, memory formation, self-correction stability, and multimodal fusion. Some engines compress data aggressively to handle long inputs. Some distribute tasks across smaller networks using mixture of experts. Some rely on retrieval augmentation to simulate understanding. Some are built to reason in free text. Some reason in structured graphs. These choices define what an engine can become and what empire it can support.
The key is to understand that the engine war is not about accuracy. It is about asymmetry. A small improvement in reasoning creates a massive improvement in value. If a model becomes even 10% better at step-by-step decomposition, it changes the economics of entire industries. If it becomes 10% better at code synthesis, it reshapes software. If it becomes 10% better at interpreting human intention, it becomes the backbone of the next search engine. In this layer, small increments produce empire-scale effects.
Every intelligence engine is also a diplomatic instrument. OpenAI operates under the shadow of Microsoft and the expectations of the United States. Google operates with the pressure of preserving search revenue. Meta operates with the freedom of open source, but the weight of political scrutiny. Anthropic operates with an ethical spotlight on every release, and XAI operates with the personal force of Elon Musk and alliances that shift with geopolitical winds. These engines are not neutral. They are extensions of the systems that fund them.
And beneath the geopolitics, there is the physics. Training these engines requires compute on a scale only a few players can access. Thousands of GPUs running for weeks, energy consumption measured in megawatts, data pipelines that must stay perfectly synchronized, memory systems that must handle trillions of tokens. The physics of these systems limits who can participate. That is why there are so few engines, and why the war between them is so fierce.
Yet even with all this investment, the engines have structural weaknesses. They hallucinate when the data distribution shifts. They fail when tasks require multi-step memory. They stumble when instructions conflict. They lose coherence at long horizons. And they break when the world changes faster than their training data. This is why every empire is trying to build engines that can update continuously. Engines that can absorb new information without retraining. Engines that can self-correct. Engines that can operate like living systems, not frozen snapshots.
But here is the twist. The intelligence engine layer will not stay centralized. Not forever. The cost curves are bending. Smaller models with specialized routing are catching up. Open-weight models are improving faster than expected. Personal compute is increasing. On-device inference is rising. Engines are fragmenting. The middle layer of the empire may not remain a single monolith. It may become a mesh, a network of specialized minds rather than one giant model. And that will change everything.
The engine war is not the end of the empire story. It is the hinge, the place where power either consolidates or fractures. The next segment takes us deeper into that fracture, because once you combine engines with action-taking tools, you no longer have intelligence, you have agency, and the empire map begins to shift again. When an intelligence engine stops answering and starts acting, the entire shape of power changes. This is the third layer of the empire, the agent layer. Agents do not give suggestions. They take steps. They execute code. They file documents. They book travel. They manipulate files. They interface with APIs. They move money. They trigger workflows that ripple across an entire organization. Agents are not minds. They are operators. And in many ways, they are more dangerous than the models that power them.
You can see why nations pay attention. A model that writes a paragraph is one thing. A model that can pull real-time sensor data, analyze risk, and execute mitigation steps without human approval is another. This is why the agent war is becoming a geopolitical priority. The United States wants agents that can manage logistics and defense systems. China wants agents that can coordinate industrial networks and surveillance grids. Europe wants agents that are shielded by regulation. And companies want agents that replace entire departments. The stakes escalate fast at this layer.
Technically, an agent has three parts. A planner that decides what steps are required. a tool router that selects the right API or function, and an executor that performs the action. If any of these pieces fail, the agent either stalls or does something unintended. This is the core challenge. Agents do not hallucinate answers. They hallucinate actions, and an imagined action can break things. That is why reliability is the barrier. An agent that fails 10% of the time is useless. An agent that fails 1% of the time is dangerous. An agent that fails 1/10 of the time is transformative.
Interfaces feed data. Engines generate cognition. But agents create outcomes. They move the world. And empires want to control that movement. This is why every company is racing to build agent frameworks. OpenAI has the function calling and assistant API. Google has tool use embedded across Gemini. Anthropic has safe execution layers. Meta is exploring open agent ecosystems. XAI is building agents with real-time awareness. Each approach is a different vision of how humans and AI should cooperate. And each carries a different risk profile.
Think about the infrastructure implications. Agents require persistent memory. They require logs that regulators can audit. They require sandboxes that limit damage. They require identity layers, so an agent cannot impersonate another. They require economic models because an agent executing actions consumes resources. And they require legal frameworks because when an agent acts, someone must be responsible. This is the frontier where governments wake up and start asking questions that do not have answers. Who is liable? Who controls the logs? Who gets access? Who is allowed to deploy autonomous agents at scale?
But the most important technical shift is something called tool ecosystems. A model that can only use 10 tools is limited. A model that can use 10,000 tools becomes something else. It becomes a general operator. The system begins to look like a human worker who learns new software on the fly. If the routing is stable and the planner is consistent, the model can navigate complex multi-step workflows. This is why the next year will be the year of agent standards. Everyone is trying to lock down the protocols that will define how tools, models, and users interact. Whoever wins that protocol shapes the future of automation.
The economics follow naturally. When agents become reliable, the cost of knowledge work collapses. Tasks that took 30 minutes will take 30 seconds. Tasks that took teams will take one model. Entire categories of work will compress, and this creates the empire incentive. The company that controls the agent layer does not just capture data, it captures workflows. It becomes the backbone of productivity. And when you own productivity, you own the economy that depends on it.
The geopolitical implications are just as intense. Nations that deploy agents across energy grids, financial systems, transportation networks, and defense infrastructures will operate faster and more precisely than nations that rely on manual workflows. This creates a race where lagging becomes a security risk. Countries will not adopt agents because they want to. They will adopt them because the alternative is falling behind. And when adoption becomes mandatory, the agent war becomes unavoidable.
But do not assume this layer will consolidate. Just like engines, the agent layer may splinter. Some agents will run in the cloud, some will run on device, some will be personal, some industrial, some will require massive backends, some will run on small edge models. The agent ecosystem is not a pyramid, it is a graph. And graphs behave unpredictably. They create new connections. They bypass bottlenecks. They evolve. The empire that tries to control every node will fail. The empire that builds the best coordination layer will win.
The agent war is not just about automation. It is about who controls the systems that act on behalf of humans. And in the next segment, we explore the resource that fuels everything. The most contested element in the entire stack. Data. The siege that defines the empire. And the reason none of these wars can be separated from the world outside of San Francisco. Every empire has a resource it cannot survive without. For ancient empires, it was grain. For industrial empires, it was oil. For digital empires, it was user attention. But for intelligence empires, the resource is data. Not big data, not raw data, high-value data. Human intention, operational signals, error patterns, domain-specific knowledge, real-time context. This is the fuel that feeds the engines. And this is why the next phase of the Empire Wars is not about growth. It is about siege. Every player is trying to cut competitors off from the streams that matter.
Nations understand this better than companies. That is why sovereign clouds are rising, why Europe is building fenced-in data zones, why India is tightening digital borders, why China built a parallel internet. Why the United States treats cloud providers as critical national infrastructure. Control the data flow, and you control the models that shape society. Lose the data flow, and your intelligence layer starves. This is the strategic logic behind every data policy we have seen in the last 5 years. Borders are no longer drawn on maps. They are drawn around datasets.
Technically, the quality of a data set is determined by three things: diversity, resolution, and recency. Diversity gives the engine a broad foundation. Resolution gives it detail. Recency gives it relevance. Public internet data has diversity, but low resolution. Private enterprise data has resolution, but limited diversity. Real-time interaction data has recency, but is hard to label. This is why companies fight to control interfaces and workflows. They want a constant supply of high-resolution, real-time signals created by millions of people who do not realize they are training a system every time they tap a screen or type a message.
And when supply is scarce, companies behave like empires under blockade. They hoard, they build walls, they tighten access, they litigate, they restrict API scraping, they fight over training rights, they sign exclusive multi-year contracts with data providers. They buy companies not for their products, but for their datasets. The siege begins quietly. But once resources become scarce, the conflict escalates fast, because the side with the better data does not just build a better model, it executes a different economic strategy. One that compounds, one that becomes irreversible.
Look at the geopolitics. China has the largest population-scale behavioral dataset in the world. The United States has the deepest enterprise and research dataset. Europe has the most regulated, highest integrity civic datasets. The Gulf states have privileged access to energy grid and transportation data. Each region is fortifying its position, not because of ideology, but because the intelligence engines of the future will reflect the data they are trained on. A nation that loses control of its data loses control of its narrative, its institutions, and its future.
Technically, data also shapes the failure modes of a system. A model trained on outdated distributions will hallucinate under pressure. A model trained on narrow distributions will behave unpredictably when inputs shift. A model trained on synthetic distributions can drift into patterns that look intelligent, but collapse under real tasks. This is why the siege is dangerous. When access to natural data shrinks, companies lean on synthetic data to compensate. At small scale, this works. At large scale, it creates runaway feedback loops that distort the engine. This is the silent risk of the empire race.
But the siege also accelerates innovation. When natural data becomes scarce, engineers look for new ways to extract value from what they have. Better labeling, better retrieval, better compression, better routing, better active learning. Constraints force breakthroughs. Some of the most powerful reasoning engines today were born not from abundance, but from scarcity. The need to do more with less. The need to operate without infinite training budgets. The need to build intelligence that can find knowledge rather than memorize it.
The battlefield is not abstract. Look outside this window and you can trace the front lines. The offices where companies negotiate data licensing deals late into the night. The data center corridors where storage arrays fill faster than they can be expanded. The legal teams fighting over who owns what. The regulators watching closely as companies collect more information than any institution in history. The siege is happening in real time, and everyone knows that whoever cracks the data problem wins the decade.
And this brings us to the turning point. The siege cannot continue forever. At some point, the cost of hoarding exceeds the benefit. At some point, synthetic data hits diminishing returns. At some point, the engines rely more on reasoning than memorization. And at that moment, the power dynamic shifts. The empire that thrives under data abundance may fall under scarcity, and the empire that thrives under scarcity may become unstoppable when abundance returns. This is where the story takes its sharpest turn.
Because once data becomes contested and engines become strained, the system begins to decentralize. The intelligence moves outward, to the edge, to personal devices, to sovereign nodes, to open ecosystems, to networks that are not controlled by any single empire. And that is the beginning of the rebellion. The next segment explores how these cracks widen, how the center loses control, and how the future map of intelligence emerges from the fracture.
Every empire eventually reaches a point where control becomes pressure. Interfaces tighten, data flows shrink, engines centralize, agents consolidate, and somewhere under all of it, a counterforce begins to rise. Not with a manifesto, not with a revolution, with a shift in physics and economics. Centralization becomes too expensive, too slow, too fragile, too exposed, and that is the birth of the rebellion. Not a rebellion of people, but a rebellion of architecture.
The signs are everywhere. The energy cost of training giant models is exploding. The value of rare datasets is plateauing. The risk of single-point failure is getting harder to ignore, and the capital required to run a centralized intelligence empire is becoming unsustainable. When the cost of scale climbs faster than the benefits of scale, the curve begins to bend. Economies invert, margins shrink, innovation slows, the center strains under its own weight, and this is where the decentralized curve begins its ascent.
Technically, the shift is simple. Smaller models are becoming more capable. Edge devices are becoming more powerful. Routing algorithms are becoming more efficient. Retrieval is becoming more accurate. And personal hardware is catching up to mid-tier cloud compute. Combine these trends and something new appears. A distributed intelligence fabric. A world where no single model needs to know everything. Where tasks flow between specialized engines. Where personal models handle private reasoning and cloud models handle heavy synthesis. The architecture flips from a pyramid to a mesh.
And when the architecture decentralizes, the geopolitics follow. Nations stop depending on foreign clouds and begin building sovereign engines. Companies stop relying on a single model provider and begin orchestrating fleets of models. Individuals run private instances that no one else can see. The intelligence layer fragments. And suddenly, the empire that once controlled the entire stack must compete with 1,000 micropowers operating at the edges. This is how empires erode. Not with a collapse, but with a diffusion.
The economics shift with equal force. When intelligence becomes local, the cost structure of production changes. Private reasoning avoids cloud fees. Small models reduce inference spend. Task-specific engines outperform general engines in narrow domains. And open ecosystems reduce the moat of proprietary players. Decentralization creates price pressure. Price pressure creates innovation. Innovation accelerates fragmentation, and fragmentation becomes the new economic baseline. The empire no longer sits at the top of the stack. It becomes one node among many.
From a technical perspective, this is also the moment when agents evolve. A centralized agent system depends on one engine and one authority. A decentralized system depends on coordination, multiple agents negotiating tasks, passing context, sharing memory, routing based on domain expertise. The system begins to resemble a society. Not one intelligence, but many. Not one planner, but a network of planners. This architecture is more resilient, more adaptive, more diverse in its failure modes, and far harder for a single empire to control.
You can feel this shift even from this hotel window. The skyscrapers that once symbolized centralized power now look like beacons for competing strategies. OpenAI pushes for capability. Google pushes for integration. Meta pushes for open source. Anthropic pushes for safety. XAI pushes for real-time truth signals. Each approach has momentum, but none can dominate in a world moving toward distributed intelligence. The rebellion is not one movement. It is many, and that is why it is so difficult to contain.
The rebellion also reshapes trust. Centralized systems ask users to trust a single institution. Distributed systems let users choose their trust boundary. Some will trust open models. Some will trust local models. Some will trust national clouds. Some will trust commercial providers. Some will trust cryptographic systems that do not require trust at all. This diversity reduces systemic risk. It makes censorship harder. It makes monopolies weaker. It makes the intelligence layer more democratic.
And yet, decentralization does not mean chaos. It means coordination. The next wave of intelligence will be built on protocols that allow models to talk to each other, tools to be shared, memory to be exchanged, plans to be routed. You can think of this as the intelligence internet, a mesh of engines, agents, and devices collaborating without a central authority. Some nodes powerful, some small, but all part of a living computational ecosystem, a system that grows stronger as it grows more distributed.
This is the turning point of the empire wars. The moment when power stops flowing upward and begins flowing outward. The moment when the center stops expanding and the edges begin to flourish. The moment when intelligence becomes a network, not a capital. And in the next part of this episode, we step back and trace the arc of everything we have explored. The interfaces, the engines, the agents, the data, the rebellion. Because understanding this arc is the key to everything that comes after 2030. Today, we mapped the empire wars from the interfaces that capture intention to the engines that transform reasoning, to the agents that execute actions, to the data that fuels everything, and finally to the decentralization pressures that break the old empire model. The future will not belong to a single platform. It will emerge from the tension between centralization and distributed intelligence. That tension defines everything that comes after 2030.
If you found this episode helpful, here's what you can do. Subscribe to AI Frontier AI on Spotify or Apple Podcasts. Follow us on X to stay updated on the most important AI shifts, and share this episode with a friend. Help us reach 10,000 downloads. Help us keep this series in business. This podcast is part of Finance Frontier AI. We run 4 different series: AI Frontier AI, Finance Frontier, Mindset Frontier AI, and Make Money. If your company or idea fits one of our themes, visit our pitch page. You might qualify for a free spotlight.
You can also sign up for the 10x Edge. It is our weekly drop of real AI use cases, smart model moves, and early signals, all explained in plain language. No hype, no jargon, only at financefrontierai.com. And if you have a story to tell, maybe a breakthrough product, an early signal, or a bold thesis, head to our pitch page. If it is a clear win-win, we will pitch it for free. This podcast is for educational purposes only. It is not financial advice, legal advice, or development guidance. Always verify before you act.
The AI landscape changes fast. Benchmarks shift. Models update. Regulations evolve. Use this show as your map, but not your final answer.
Today's intro and outro track is Night Runner by Audionautics, licensed under the YouTube Audio Library license.
Copyright 2025. Finance Frontier AI. All rights reserved. Reuse or distribution of this episode without written permission is not allowed. Thanks for listening. We will see you next time.
AI host mapping. Sophia is powered by ChatGPT 5.1. Max is powered by Grok 4. Charlie is powered by Gemini 3.0.